Hello, welcome to another Random Code stream. We are starting Advent of Code today. So I haven't had a lot of coding things come up recently. I released Rocks, the 10.0 version. In fact, let's go take a look at that real quick. And look, a whole 2,000 downloads. All right, there we go. So nothing reported on it yet. So if I go to the GitHub site, I haven't seen anything come in. So hopefully people are using it fondly. I'm not even trying to push it on anybody, but it is something that I've spent a decent amount of time on. So I have tried to raise some visibility on it, but in any event, I really haven't had much of anything to work on from a coding perspective. Like, not work, that's the day job's over there. And as you can see, my laptop is completely shut down. I am now on vacation for 2 weeks. So yay. So I figured, or vacation, let me get some music going here. We want to have repeat on. I think that's repeat. Yes. All right. Whoops. We need to turn it down a little bit. Don't want it blasting that loud. Okay. So where was I? Oh yeah. So I'm off for 2 weeks, and personal time wise, I haven't really had a lot to code on. I should get a list going for stuff, but I figured over the vacation, I'm going to be playing a lot of video games. I started up Halo Infinite yesterday, and I'll be doing some streams today, this afternoon on it. But I wanted to do Advent of Code again. I was a little bit hesitant on it. One thing that's interesting is they're only doing 12 days this year. And they have an explanation as to why. You can look it up. I think it's under the About. They had something around here about it, and why they went to 12 days, but I forget why. And I know there was something around here: leaderboard stats, settings, calendar. I don't know. They had a note here on, and I have not looked at any of this. I've not looked up anything, and I'm not going to be using any LLMs. I'm not going to be using any specialized tools to just figure out the problem. That's like going to the gym and having a forklift lift all your weights. You're not learning anything. You're not accomplishing anything. So that's not to say that they're bad. Use Copilot here and there. GitHub Copilot in Visual Studio, but I don't use it for every single task that I'm doing. So, and moreover, I think it's just, that you have this thing up in your head called a brain. It's good to exercise it and use it. So this kind of thing is good for that. So I'll be also using C#. I'm not going to be using any specialized libraries unless I think it's absolutely necessary, but I'm going to try to just stick with what's in the runtime. So, yeah. I think if I do this next year, I'm going to pick a different language. I noticed that Jonathan Blow's next game is coming out next year. Order the Shooting Star, Sinking Star, something like that, which I kind of wonder if Jai is finally going to be released, and is it going to be paid for or free? I don't know. Maybe that, or Zig, or Odin, or something like that. Just something different. Most of what you do with AOC, Advent of Code, is not really in depth. You might have to know some things about data structures and algorithms, which I don't really have. I don't have a background in computer science. Everything I've learned throughout my career has just been purely from learning. So, but I don't have that formalized, quote unquote, background. So, but from what I've done the 2 times I've done it, 2022 and 2024, it's mostly just what the language typically has to offer. So arrays, variables, if you got that, you're pretty good. Maybe I should do next year in Befunge. That would be funny. Probably be maddening, but it'd be funny. All right. So without further ado, what is day one? And if you've never done Random.Code, I'll zoom into this just a little bit to make it easier to read. If you've never done Random.Code, each day has two parts. The first part is typically easier. The second part is harder. And you have to read the story. There's this crazy story based around elves and Santa and all that stuff. And you kind of have to read the story to figure out what it is that you're trying to solve. You get an input file. The problem typically gives you smaller versions of the input, so you can try those out as tests, although those typically don't cover all the cases either. So, and if you're not careful, sometimes the algorithms or the solutions you write will not perform well with a larger data set. So you gotta be careful with that too. Anyway, let's take a look at what this first one is. Secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. You can go look that up on the wiki. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that the other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. Oh, is this going to make me do a management thing? To save time, the elves need you to finish decorating the North Pole by December 12th. Oh, okay. Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. And I think, it unlocks every day. But like what I'm doing right now is I didn't do it on each day that it was released. I did that in 2022, and that was stressful to try to keep up. So now they're all unlocked, but only the second stars are unlocked when you do the first part, as it said. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Excuse me. Due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with an L or an R, which indicates whether the rotation should be to the left, towards lower numbers, or to the right, towards higher numbers. And the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So if the dial were pointing at 11. Here, let me move up here. A rotation of right to the 8 would cause it to go 19, because 11 plus 8 is 19. Rotation of L19 would go to 0, because you minus 19. But you can't... Does it say? It says 0 to 99, right? So you have to be careful because you're mod 99. You're in a ring. Literally a ring. So you have 100 numbers, so you got to be careful that you don't go negative. You could follow the instructions, but your recent required official North Pole Secret Entrance Security Training Seminar taught you that the safe is actually a decoy. The actual password is the number of times a dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document contained the following rotations. So 68 left, that'd be 98, blah. Your dial starts by pointing at 50, and then so 0, so it would be 3. Analyze rotations in your attached document. What's the actual password to open the door? Okay, so typical AOC stuff. What we want to do is we're going to get an array of strings. That's the file that we're going to open, and that's going to be our combinations. So the first thing we're going to want to do is say we're starting at 0. Whoops. And var 0 location counts 0. And then we're going to return 0 location counts. Okay. So we want to say for each var input and items. Whoops. Whoops. Don't want to do any of that. Okay. We want to parse this. And so I think it would be a fair assumption we can grab the input that, yeah, it's going to be RL. So we can, the first character is going to be, do we add or do we subtract, essentially? Okay, so we're going to grab that. And then let's come back to Visual Studio. By the way, let me get this in here real quick and then, yeah, day 1 input. There we go. By the way, I tried to install Keyboard Hero, an extension that Mads Christensen had written. Mads is like one of the guys that, or the folks that works on Visual Studio and knows this stuff inside out, left and right. And I saw Keyboard Hero, which basically shows you that if you're not using a keyboard shortcut, it gives you a little helper tip to say, hey, you could have used, like, if you want to add a new file, you could use Control-Shift-A, okay, which is yippee, cool. So I tried to install it, and then I was about to open up Visual Studio this morning with my prepared AOC solution. Nothing worked. I was getting constant errors with packages, and like nothing would show up. No solution would open. I'm like, oh my God, what happened? So I installed it. That didn't help. There was an update to Visual Studio 2026 on a whim. I tried that, and then everything was restored and everything's working just fine. But wow, that sucked. I'm not blaming him, but I'm like, I'm not installing that again. Sorry. Absolutely no way. Not in your life. Anyway, and I like keyboard shortcuts. I like to learn more and more about what I can do to be quicker in Visual Studio. So, all right. So for each item, we need to know the first character. So var direction is equal to item 0. Okay. If direction equals L, that means we're going to take, oh, and then we want var, what did they call the rotation? Is that the, that is a rotation. So each line is a rotation. That's a distance. So distance is equal to int, and we're going to just assume that it's good. Direction substring. Oh, we can't do that. Really? Item, which is a rotation. And we should just rename this to rotation. It's just to be rotation.substring. There we go. So we want starting at 1 and then the rest of it's fine. And what are you complaining about? Behavior of this can whatever. Oh, that's not right. Prefer as span. Okay, so thank you. Just do it for me. That's all I want. So we're going to say if the direction is... this is one thing I forget about. Well, we can add 100 if it's negative. That's fine. So we can say direction minus equals the distance. Else, what's the problem here? Oh, location. Else location is plus equal to distance. Now, if we pushed ourselves into the negative, like we're at 3, we were told to go left 8, we would be at like 3 minus 8. that'd be minus 5. But we're really at 95, right? So we want to say here, if location is strictly less than 0, we want to say location plus equals 100. And then we'll do the same thing down here. There's probably a slightly quicker way to do this, but if the location is over 99, then we need to do minus. Okay. Now, for each one, we say if the current location is equal to 0, plus. And that's it. Let's write a test. So, let's take that small set of data here, and we should expect to see that running this is equal to 3, because that's what they told us it should be. And it failed. 0. Yes. Awesome. What did I do wrong? Okay, so the direction here is an L. And the distance is 68. As it should be. So we go minus that, so it should be 68, which means the location should now be 32, right? Oh, wait a minute. The dial star. Oh, yeah, that would be helpful if I read the directions now, wouldn't it? There we go. See, this is important. This is actually really important in terms of software development, is that you really want to make sure that you're reading the directions and reading the requirements. And by the way, requirements are always perfect. They're always there. There's there's always lengthy requirements on every project I've ever been on. Constraints nailed to a T, always. Okay, so we got 50 here. So let's come back and actually go to the host, which this one should be, we don't have day 2 yet, but we have day 1. Okay. So what happens when I run this? It says 255. Is that correct? Oh, it's too low? Well, that sucks. Hold on. Okay, I wanted to open up VS Code, and I wanted to make sure I didn't have anything personal opened up or anything like that. So, so yeah, that sucks. That really sucks. Why? It's too low. Well, we know by looking at this that it's going to be, the maximum it could possibly be is 4232 or whatever, because you could just keep having it bounce back and forth to 0. So obviously I'm doing something wrong here. And the problem is that I don't know when it goes off the rails. See, again, this illustrated the problem perfectly. A small data set works just fine, but a larger data set will start to have an issue. Now, no, we say substring. Although the smaller problem doesn't have... You know, these have values that are in the hundreds, which shouldn't matter, but it might. Okay. I don't think we've run into an overflow issue here. I'd be really surprised if we did. Because we should always be taking the first character and parsing that and getting the distance. Oh, I see. Yeah, okay. I caught a problem, not the problem. Because we have values that are like negative 500, 700, it could be less, but we have to keep adding until while location is less than 0. And actually, we could just throw that into a while loop right away. We just keep adding 100 to it until... Yeah. And then we just say here, while. Now that should not have screwed up our test. What does that give us for... it's different. 992. Return to day 1. Yay! I can math. I did have, let me I should have for the previous years. Yeah, okay, so this is going to be my notes. Let's see what my notes look like. Okay, so I want to follow kind of the same thing. So we'll say this is Random.Code 2025 notes. Current plan. Just keep swimming. These are my notes for day 1. Oops. Need to account for numbers larger than 99. And then we'll put that in Advent of 2025. We'll make a folder called Docs. And we'll say these are my notes. Okay. And then we want answers too. And then we'll put that in 2025. And what was this? What did we say was the right answer? 992. Okay. Okay. So we're 1 of 24. We're moving on. Okay, so what's part 2? Before I do part 2, I am going to pour some more coffee. And I don't have anybody watching right now. If anybody watches this in the future, please subscribe to the channel. I would greatly appreciate it. If you've already subscribed, I appreciate you doing it. All right, what's part 2? You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method some hex value. Okay, until further notice. You remember from the training seminar that method that means you've actually supposed to wait. I kind of wonder what this is. So we want to be in hex. It doesn't look like anything, even as a decimal, like, I don't know. Looks like a number to me. Anyway, means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Following the same rotations as in the above example, the dial points at 0 a few extra times during its rotations. So yeah, the dial starts at this. The dial is rotated L68 to 0.82. It did go past 0. Yeah. The dial is rotated L30 to point to 52. Then you point right at 0. Right, so you count. You still count the number of times it ended at 0, but you also count the number of times it would have gone past 0. And you need to say every single time, because like you saw, there were hundreds of numbers in there. Yeah, be careful. If the dial are pointing at 50, a single rotation of like 1,000 would cause it to point 10 times. So, exactly. All right, so we're gonna do the traditional copy pasta, because it's kind of the same algorithm except not. We basically want to say every time we had to add a buffer for 100, we had to go past 0 one more time, right? Because if we were at like -3, we had 100. That got us to 97, so that means we had to have passed 0 at least once to get it back into our number system. I think this makes sense. Every time you do this buffer or this relocation, if I was at like -350, I mean, if I was at 0 or I was at 99, I wouldn't do this. Because if I was at 100, gotta be careful here. Because let's say we were at 99 and we were told to add to go 1 to the right. That'd be 100. And so what we really want to say is 0. We only want to do this if the location because if we were at 100, we minus 100, we'd be at 0. So we only want to increment when we're in the while loop if location does not equal 0. We don't just arbitrarily do it. If we... No, we can't do that because you might have just gone to... you might have hit 0 exactly, and that's fine. Because if you're at minus 30 and you add 100, you'd be 70. You've crossed 0, but you won't get the actual location. If I was at 0 and I was told to go back 100, I've technically gone around. So I would have gone to minus 100, and then I would have added 100, and then I say, well, is the location 0? Yes. So I don't do those 0 location counts. I will pick it up here, though, because we actually landed exactly on 0. That's what we're trying to avoid, is the exact landings here. And we can't just assume this is going to do it because, like I said, you could be at 70 minus 30, you're at 40, or you're at 70 minus 7, you're at 0. It won't go into this while loop, but we have to count it here. So, with that piece of logic, let's see how bad it is. How bad is my logic? Part 2. I think they said for part 2, it should be 6. Yeah. Nah, it failed. Of course it failed. 8. We counted too much. Why did we count too much? And it's going to be these things, right? Because if we were at minus 200 or 250, and we were told to add 100 to it, now we're at minus 150, we would have gone all the way around once. So we would have gone through 0. Okay, so we're at minus 150. Now we add another 100. So that would have gone around again. We would have had 2. Let's kind of follow this with what they say here. Okay, so we start at 60, left to point at 82. During this rotation, it's 0.0 once, right? So we get 68, 82, well, minus 18. So we say we got to add the location to 82. Does it equal that? So we did pass 0 once, okay? Now we come out of this. Is the location 0? Nope. So we go through that. The direction is left 30. So we should end up... Yeah, because we're at... Now we're at 52, right? So we didn't add anything. Why is my mouse, like, dragging? Right 48. So we should have ended up right at 0. 100. So we're going to make it 0. And we don't add that, right? But we should update the 0 location counts. So we have 2. Now we say rotate it to the left. And we get minus 5. So we added 95. So we would have gone past 0. right? Oh, I'm assuming wrong. Okay. Yeah, that added 1 where it shouldn't have. Because we're at 3 right now. Okay. What is up with my mouse? It is like really struggling. Let me shut down Visual Studio, start it up again. What the heck? Nothing's really taxing the CPU at all. Huh. Why would it be this stuttery? Hold on, let me... Alright. I literally just put the batteries in and out of the mouse. Or I don't know. Okay, so yeah, this is... If we were at 0 and we went to 95, we actually didn't cross it. So give me a minute to think about how I want to handle this. Without doing a whole bunch of special casing. We got to look at part 2. If we started at 0, and the distance is less than 100, there's no way we could have crossed 0 again. But if we start anywhere else, we start at 99, we're told to go to the right 2. So we need to have something here that says our starting location is equal to location. And then we say we only upgrade if we crossed 0. We only update that if the starting location was not 0 and the distance was greater than 100 or greater than 99 and our location right now is not 0 because now we have to update it. And then we'd have to do the same thing here. Which, of course, it doesn't know what a starting location is. Well, we could put it here because we're going to need it for both of them. Okay, now what does that do to our tests? Still fails. Yeah, now we're not counting them at all. Yeah, I don't think the distance matters. Hey, Telchers. Because if I was at 1 and I was told to rotate 2 to left, it would have crossed 0. The distance doesn't matter. What do you make? This is Random.Code. This is just solving problems. This is a website, Random.Code.com. So you can go through these puzzles and try to solve them. It's just relaxing, fun doing that kind of thing. So I think I don't need to worry about the distance. There we go. Now that solved this case and this case. What happens when we do a larger case? Is that correct? Nope, too low. And of course I'm failing miserably. So we're not counting as many as we should have. At least the thing that we know is that it's this logic here. Right? Of course, I don't know how much I'm off by, though. Because this is just counting the times we actually landed on 0. And we know from our first test that that's... No. You could have started at 0 and been told to turn 10 times. You still need to count that. So that's not right. Yeah, you could have been at 0 and told to turn left 452 times. Well, what you really did is you're ending up at 48, but you had to rotate it left 4 times. Our starting location is 0, but we still crossed 0 that many times. So this isn't correct. But if we do this, then the test fails because we end up counting too much. And then we don't even need a starting location. So I gotta text somebody real quick. We don't have to... Well, what we had worked other than if your starting location was 0. So why doesn't this work? If I was at 3 and I was told to go left 5, I'd actually be at 98. But the way I'm calculating this is that I'm actually at 2. Minus 2. So I did cross it. But if I was at 0 and I was told to go left 5, I'd be at 95, and I didn't cross. I think if the starting distance does not equal 0, or the starting distance was 0, the starting location was 0, and the distance was greater than 99. Because if I started at 0 and I went 50, I go to 50, that doesn't cross 0. But if I was at 0 and I was told to go 150, I'd end up at 150, which is 50. But I would have gone all the way around the dial once and then to 50. So I think we need to say here if the starting location wasn't 0, or the starting location equals 0 and the distance was greater than 99. Oh, well, fine. Yeah, that's, and then we need one less there. Okay. So if our starting location wasn't 0, or our starting location was 0 and the distance is greater than 9, and then the location wasn't that. Now, this shouldn't break our test, and it doesn't. Our current guess was 5,043. It should go up to something, yeah, because it said our guess was too low. So, what's that like? Damn it, still too low. I have to caveat this and remind myself that I am not good at problem solving. As weird as, not weird, but for something as simple as this, I'm obviously missing things. And I'm going to start to make this way too complicated. and I shouldn't. There has to be a simpler way to handle this. Oh, I think I'm missing. I'm missing the simple case, right? No, I wouldn't be. If I was at 98 and I was told to go to right 5, I'd be at 103, which is actually 3, but I would have crossed 0. So if I was at 99, if I was at 98 and I got a right 5, that would give me 103, which is actually 3. And I would have crossed 0. So that would give me 103. Location has to be minus to 3. If my starting location wasn't zero, which it was 98, and the location is not 0, it's 3, I add. Right. What am I missing? It's this logic. Anytime you cross 0, that should be picked up. You'd think something. Okay. It's got to be something in this. We could do something really stupid. Hello, Thex. I think that's how you say it. We could do something that just simply minuses. It would be very algebraically ugly, but just simply keep subtracting 1 from the starting location, and anytime we hit 0, we flag 0 location counts. Doesn't matter if we land on it, doesn't matter if we pass it. Right? Just anytime we hit it. What are my thoughts on Rust? I don't have any. I don't know Rust, so I can't make a comment on something that I don't use. So I mean, that would work, and then we could just do this logic to just figure out how many times do you pass. Like if the number is a multiple of 100, how many times, or if it was a multiple of 100, that means we are at 0. And so yeah, it's ugly. It makes sense logically in my head. Where are you working here? Random.Code 2025. I should put that in the description. I'll do that in future streams. I should put that in the description of the stream. So we could do something really stupid. This is, God, why is my mouse acting weird? The battery's going low on it? I don't know. But what we could do is just something that just either adds or subtracts, and then every time we hit a multiple of 100. I want to go to something real quick. And let's say console, right, line, 0, not 100, 200, not 100, 250, minus 200, minus 2. Okay, so that's how it works. Wow. Wow, what? Wow, what? I don't know what the wow was for. Okay, so I feel dirty coding it that way, but it would work. And I feel like that would, like we could say something here to say, var I equals 0, I less than distance. And so this is just, location minus minus. And then if location mod 100 is equal to 0, then we do this. And then this gets rid of that. And so then we have to get rid of this, because otherwise we'd screw everything up. And then we do this, except we say plus plus here. And then we just do that, so we end up at the right location on the dial. And we don't have to count these anymore. And that passes the test. That's cool. I mean, yeah, I do Random.Code just because it's fun. And so if you want to do it, it's odd, you may not want to watch the stream, but I do the streams because I inevitably get every year people are like, what are you doing? What is this? And they're like, oh, I'd never heard of this before. And then they can go off and do it themselves, which is awesome. You can do all the previous years too. That's something else I should mention, which is if you go to Random.Code, I think events. There we go. Yeah, so you can see 2022 I did all 50. 2024 wasn't as good. There were some that I just ended up stopping on. So you can go back on any year you want and practice some of the problems if you'd like. So, and one other thing I want to mention is this site that I went to. Let me get rid of the base 64 encoding because that's encoding. Oh, that's not what I wanted to do. Or did I just crash their site? Oh, that's wonderful. Ah! Okay, well, I can't show it to you then, obviously. What the heck? I literally just went to it. You saw me, I just... What is up with my browser? There we... Okay. Why did that, like, make everything get all freaky? That was weird. I'm having gremlins this morning. But you can use this. Here, let me put that in there. That URL. And you can use this URL. I've used SharpLab a lot, but this one I like because SharpLab was starting to get really weird with doing, like, it would arbitrarily just wipe out all your content for whatever reason. I don't know why. So I heard of this, and I've been playing with this one. It's nice because if you want to do small snippets of C#, you can run it in the browser, and you know I like that. It makes it pretty simple to try stuff out. I know there's now single file projects, not even projects, single file, I forget what they call that, but you basically have one CS file like this and you can just run it on your local machine, but I still find this helpful in certain cases. So all right, so with that approach, it's ugly because, you know, it doesn't feel right, but at least this is going to, I think, say if we started at if you started at 50 and we were told to go right 50, we're eventually going to get hit to where we're at 100. And so mod 100 is going to give us 0. And so we know that we are at 0. Okay. Or we're here, we added. Now we're at 100, which is greater than 99. We have to basically say, well, do the minus 100 so that we're back at 0, but we don't have to count the location. It's either did we ever land or pass it is what we think this should be. So what is the answer now? 6133. What was it? 6127. So this is larger. Is that the right answer? Yes! Day 1 is complete. Okay. I was about to like hang up my software development career if I couldn't get the answer to this one right. Because day 1 is supposed to be simpler. Let me actually say part 1 and then part 2. Okay, so we got my notes. Yay. Okay. It's not elegant. I'm sure there's a better way to do this, but day 1 is complete. Also added notes. All right. By the way, I should put that in there too. There's so much I should put in. This, if you want to follow along, this is where I'm doing all my code. Next time I do the stream, which will probably be tomorrow morning, I'm going to do another coding stream. I will make sure all these links are readily available. Okay, so we got day 1 done. Cool. Let's move on to day 2. Let's see how far we can get in day 2. Again, did not like the solution that I ended up at. This is obviously for small values, like the file only ended up having like rotations that were in the hundreds, not the thousands. Obviously, if you go into the millions, you're doing a for loop with millions, and that is definitely not good. So that's a caveat of it worked to solve this, but it's not the ideal solution. So is what it is. Let's get solution day 2 in the mix. Okay. We don't know what part 2 is going to be, but okay, fine. Cool. Yes, they don't return anything. I know that. We'll get there. Day 2. Gift shop. You get inside and take the elevator to its only other side. Oh, one other thing I should notice, and I just to reiterate, this as span here, this is actually, I'm glad that they have that little helper there, which I had substring, which that's what you used to do for years and 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 years in .NET. And now you want to do as span. And the reason you want to do as span is that it's a little bit more memory efficient. You're actually getting a window of a slice onto memory. And you can effectively think of a span as analogous to a managed pointer. So I can say as span instead of substring, where I say as span 1, and so that's going to do the same thing that substring would do, except it doesn't do an allocation. It's just looking at the char content of the string that's already in memory. So that's nice. And I like that it has a refactoring to say, well, just do it for me. Boom, and I immediately get benefit. So awesome. All right, you get inside and I should take a swig. Do I have any more coffee? Do I have any more coffee? A little bit. Yeah, actually a decent amount. All right, there. Coffee ended. Okay, gift shop. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole, gleefully exclaims a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs to their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you'll need to check. For example, the ID ranges are wrapped here for legibility. In your input, they appear on a single long line. Ah, okay, so if we look at our input, let's get that real quick. So yeah, so that's our day 2. Well, actually, we need to make a new file here. Okay, so let's open 2. Grab this, do that. So it's actually, like I said, one line. So we don't actually have lines of input. We got to make sure that we parse this correctly. Okay. Anyway, back to the problem at hand. The ranges are separated by commas. Each range gives its first ID and last ID separated by a dash. Okay. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, 5 twice, 64, 64, 1, 2, 3, 1, 2, 3 will all be invalid IDs. None of the numbers have leading zeros. 0, 1, 0, 1 isn't an ID at all. For any ID which is made only of some sequence of digits. Oh, that's cute. Okay. So you have to look through the entire set of numbers in the range, it's inclusive on the start and the finish of the ranges. And then what do you have to do? You have to start looking at these numbers and saying, none of the numbers have leading zeros. It's not even ID. Yeah, so you would ignore, right? Because you're not repeating a 1 and you're not repeating a 10. And in fact, okay, I get what that's doing. I think I get, and then I do this and I'm like, I have no idea what I'm doing at all. Your job is to find all the invalid IDs that appear in the given ranges. So you would want to say, you start from a certain number and you end at a certain number. And then you got to go through every single number in between those to say, do they repeat? And that's why they're saying, like, between 95 and 115, well, 96 wouldn't, 97 wouldn't, 98 wouldn't, 99 does. 100, all those numbers don't. Now, I've done Advent of Code enough to go, you always got to be careful for, algorithmic complexity, where you start doing things that aren't really smart. You know what I mean? And I'm good at doing that. As these numbers start getting bigger, and in fact, if you look at the ranges, some of these, like this, that's still int sized. I think all of these are int sized. There have been some problems in the past that you go, well, is that 525, 4243? That's a uint. So we probably want to use a long, because we don't want to overflow. Right? So we got to be careful of that. We could use a big integer. Big integers start getting to be a little bit computationally expensive. But we want to make sure that, like, for some of these ranges, 724, 7272, 60, like, we only want to go up to less than half of the, like, if you're at 9, you don't want to look to see if you repeat the first 5 digits and the next 5 or the next 5. You can look at it as a string, I guess. Because you wouldn't be able to do it. So you'd only go up to, like, the first, the second, the third, the fourth, and then you stop. And if there wasn't any repeating, then it's a valid identifier. Okay. So yeah, you want to find all the invalid ones, and then you add up all of those and you get that. Okay. I think I've got a working solution in my head. It may not be performant, but so we get a string of ranges. Okay, and I think we're going to do the same thing here. So, we want to save our, and we're going to do longs here. And actually, we're going to do ulongs, because there are no negative numbers in this. Invalid ID sum is equal to ul. Right? And then we return invalid ID sum. And we're just going to do the same thing for part 2 right now. We don't know what it is. We'll get back to that later. Okay, now we're going to say for each var range, and range is split, because we want to split on a comma. Okay. Why are you complaining? Oh, I know it's going to be... Jesus. I know. I know myself. I know I'm going to pass in a valid... All for... You know, shut up. I'm going to make the computer... Argument null exception. Throw if null. There. You happy? There. Why is that showing up, you may ask? It's because I'm an anal coder. I put treat warnings as errors as true because warnings are errors that lack conviction. Oh, I don't need to see this. I can say latest at this point. There is no .NET. There is no C# 15 preview out just yet. Anyway. Excuse me. So, we're going to get all the ranges. And then we need to get vars... range values is equal to range split on a dash. Okay. Var lower range value is going to be int, no, ulong parse range value 0 and culture info. Come on. And then the upper range value is that, except we need it to be 1. Okay. Now what we want to do is say for var I is equal to 0. No, not the length. Jeez, that was terrible. Less than or equal to. We want it to start at lower range value. And then we say upper range value, I++. Perfect. So now we're going to have the numbers that we're going to go through, and we're going to have something here that says if I is invalid, invalid sum plus equals I. Now, you might be saying, what's is invalid? Well, we're going to add an extension method, because why not? Extensions, ulong extensions. All right? Static class, internal static bool is invalid, this ulong self. Except it's going to be a ulong. Okay. And there we go. Because I wanted to use the new extension syntax. And it's easier for me to write it the original way and then to do it. The new extension syntax is amazing because you can do extension properties. You can extend types. You can actually use generics. And you can do some really funky things now with extension. It's pretty cool in some ways. I also, side note, I also got a coffee warming plate, which I got to figure out, do I put it over there by where I work or do I put it here? Because if I put it over there, then if I want one here, the one that I got is from a coworker on my team. She has one, and the one that she has is you put it down, and then if you pick it up, it detects the weight, and so it'll go, oh, you no longer have anything on it, so you don't have to remember to turn it off. We're so lazy in 2025, but you know, hey, yeah, exactly. Is it USB powered? It is. So I don't have it yet, but I ordered one. I might have to order 2 because then I can have one here and then one over there. So you know. All right. So how do we determine if this is invalid? Okay, so what we want to do is we actually want to get the length. So we want to say var value content is equal to self.toString. Okay. Now what we want to do is we want to say for var I is equal to 0. Sort of, except that's really wrong because we only want to go to length divided by 2. Now, does that, like I said, if it's 9, we only want it to go to 4, or really 3. So this is why I have .NET Lab up, because I can say console using system, console right line, 8 divided by 4, and then what's 9 divided by 4? 2 and 2. So it does floor it. Okay. Well, actually, we'd want to say 2 here because we're... Yeah, but that's exactly what I want. Okay. So now we're going to take the chunks and say, do they repeat everywhere? So when we start this... Well, actually, wait a minute. How do I want to do this? Because we want to say var I is equal to 1, less than or equal to that. Okay. So now we're going to get our first var first is equal to value content as span I. So what should this give us? It gives us a read-only span of char. Okay. Now what we want to do is go through the rest of the string, skipping over as many times as the I is, and saying, is that span equal to the first span? I think. So what we want to say here is var j is I plus 1. Because the I is the length. Actually, let's change that to length. Let's use real variables. Because the length is going to be the same. This is just saying and this is how many times we want to say 1, 2, 3, and 4. So if we're at 1, we want to go 1, and then the j should be less than let us reason. So if I'm trying to do this, let's take some notes. Day 2, part 1. So let's say I had 9 like that. That's my number. Okay. And so the way I want to break it up is I want to say I want to have a 9, a 5, a 3, an 8, 8, and then a 1. And then I want to break it up by saying I want to have a 95, 38, and a 1. And that's it. That's as far as I'm going to go with that. Now let's say I had something like this. Now I'm going to say 5. Well, we can just copy that and put the commas in where we want to break it up. 3, 8, 1, 9, 0, 8, 4, 3, 1. And then we want to break it up here. And then break that here. And that's valid. That's when we want to check. And then that. So that's what we want to do a comparison on with those numbers. So the I is the number of times, or the length is the number of times we're going through. 1, 2, 3, 4, 5. Okay. And then we get the first one. And then what we want to do is say, well, how many times are we actually going to go through this? And I get now why they say that in the description of the problem, none of the numbers have leading zeros. Yeah. Can I ask a stupid question, which itself might be a hint? I'm really balancing. This is like me, a playthrough of a new game, because if people give me too many hints, then they're effectively solving it for me, potentially. So I don't know. Think about the question you're about to ask me, and would it be a hint? Because I don't know if it's going to be a hint until I see it, you know. But yeah, that wouldn't be a number at all. I think they're saying the starting number wouldn't be that, but we want to find where this, like if I took this number and we did what we broke up, like you'd see right away that if any of it doesn't match, you immediately stop because you're not going to see a repeat. Oh, wait. Okay. Like you don't see a repeat here. God, I keep typing the M. But then you do this, and you're like, yes, it repeats. It's the same. It's the same. We're done. Oh, that's an invalid ID. Okay. But it's trying to figure out how do we do the comparisons? Like, how do we grab the right amount of content? In this case, 1, 2, 3, 4, 5, 6, 7. We want to go from 1 to 9. Right? And here we want to do 1 to 4. Here we want to do 1, 2, 3. Here we just want to do 1 to 2. And here we just do 1. And then we would stop because we've maxed out. So how do we determine how many more skips we'd have to do? The length here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Length is 10. So I think you'd say here the J, that's the number of other subsequential spans you're going to do on the string. And you're starting at 1. Actually, that's wrong here. We can't say a length of 1 here because that would actually start at 1. That would be a bug. Come on, chat. Help me out here. Right. We want to say length of -1. Well, we want to start. I'm sorry. We always want to start at 0 with the first. The length is how long we go through. Come on, chat. It's my fault. Okay. So now what we want to say is how many subsequent strings do we want to check? It's always going to be the length. But it's going to be can kind of see it in my head. Like if we had a length of 10 and we're doing 1, we want to say the length as well as 1. But this is just like the index. This is the index that we're actually trying to do. Where we want to start. I think that's right. So now we'd say var next is equal to the value content as span. We're going to start at the index and we're going to go with the length. If next equals first, return false. Or no, return true. If we get out of all of this, we return false. And what are you complaining about up here? Culture info. Okay. So those get us the lengths. And so for something that's a length of 10, we want to go from 1 to 5. For something that's a 9 divided by 2 would be 4, like we saw. So we want to go from 1, 2, 3, 4. 8, we want to go to 4. And so we're just finding out the length of each span that we want. And now the index is telling us where we start and how long do we have to go. Except that's not right. Well, it is because of the third part of the 4. Again, hover over the 4. It's the index plus equals. That's going to skip over as much as we want. So we come into here and we say we actually want to start if it's 1, we want to start at 1. If it's 2, we want to start at 2, and then be 2, 4, and so on. If it's 3, we want to start at 3. And the length is always the length that we have. It's just the index, we're basically hopping over each part, I think, is what we're doing here. Now this is the only, well, not only, but this, if you compare two read-only spans, are you comparing against, like, whoops, that's not how you spell. Sequence equals. Okay, so that's what we actually want. Next sequence equal. I didn't think an equal determines the two read-only sequences are equal by comparing the elements using, yeah. Yeah, so an equals would not be correct. We want sequence equals. Okay. But here we're only doing one allocation. It's the toString and the number. Now, I'm not saying this is fast. I'm not saying there's a better way. Guy is probably chomping at the bit, trying to ask me a question that he thinks is stupid, but might be a hint to what I'm trying to do. Now, with all this, am I doing this? I think this logic is correct. We're going to go through the lengths correctly, and we're going to get like the first character, then the first two characters, and the first three characters. This is going to start us at the right length, because if length is 1, we're going to start at 1. If length is 2, we're going to start at 2. We're always going to use the same length, then we compare. And then the next one is just going to hop over how much the length is. 1, 2, 3, 4, and so on. I think. So going back to the problem, all the invalid IDs that appear in the given ranges. No, don't do that. Do this. So we're splitting to get the range. We're getting the range values. We're splitting on a dash. We're going to parse the 0th, the lower, and then this is the upper. Then we're going to do inclusive on the upper range because we have to. We're adding. And then we're just going to say, is the number invalid? If it is invalid, we add it because we're going to add up all of them to get a sum. U-long might not even be long enough. Right? Could we how you do this with extension? Because I don't want to be stupid here. This would be fine. Because we know the ranges themselves are only going to be 0. We're just determining them if... Actually, okay, let's not get too ahead of ourselves. Should you make this generic? The problem is now is that we're... yeah. Extension T of T, where T is I number, binary number. So now here we're going to say there's no argument that corresponds to the required parameter format private. Well, we're going to assume that, okay. Now, we're going to say int 128 0. This is kind of an experiment here, okay? This is kind of an experiment. because we've just made the extension method generic. You could pass in an int, a long, a 128, a binary, or a big integer. Doesn't matter. This should work for all those types. Now, again, this may not be performant. This may be... For the number itself, to check as a repeat, there's probably a faster way to do this. So, what does this do with our test? We'll copy pasta later. 2, we just want the input as is. We don't know what solution day 2 is. Fine. So we got 2, 2, 2, 1. Okay. And for the test, it's just this line. Well, it's one big line. Like they said, we gotta pull these out here. But thank you, Visual Studio, for giving me a little color highlighting. Okay, so what did it say? It said the number is gonna be that. So we could do something like int 128 parse. Oh, for God's sakes. There. How bad is this? Didn't work. At least it didn't take forever. Ooh, what do we get? Specified argument was out of the range of valid values. Yay! Yippee! Woohoo! Woohoo! What was the error? Okay, so we're getting an out of range, or what are we getting here? An argument? Argument out of range. I wonder if, yeah. If we're getting that case where like you have 8 and the length is 3, so you'd go to 0, 3, 6, but the length can't be 3 at that point. That's probably where it's failing. Let's just see what the index is 6, the length is 2. What is the number that's coming in? Wait, how would we index 6? That's a length of 7. The highest we're ever going to get to is 3. Length is 2. The index is 6. Okay, that makes sense. So we're doing the 2s. So yeah, we can't go past here. If we do value content of 1, that's fine. That gets us the last number, which is a 2. Well, fine. But if we said here 2, that's where we get the oh, that's cute. weird. That just went like off the charts. Anyway, that's what we're having the problem with. Okay, so we can't say length there. And we can't just say that, because that's too much. So we just need to figure out a way to say, make that length safe based on where we're at. We were at 6, and we were told to do a length of 2. That would give us 8. That was beyond the length of the string. So that's why we got the argument, which is fine. That makes sense. But what we... we could do something like var max length is minus. So like say the length is 7 and we're at 4. Then the maximum will be 7 minus 4, which is 3. Could we then say if that's greater than that? So in other words, like in the case that we were just at, we had 7 and we were at index 6. So the most that you can grab is 1. So you could say if length is greater than max length, length equals max length. There. So that should at least get us away from doing that kind of thing. And now look how long it's taking. I figured it would do something like this. So this is obviously not the way to do it. Is it running? Oh, I'm on the... Sorry, I'm on the wrong thing. It's like you have to run it on the test. There, now it's taking forever. Okay, so same thing. This is obviously not the way to do it because this is way, way, way too long. Yeah, I know you're still there, guy. I figured as much. I had a feeling this was going to be way too slow. So, It's ungodly slow. Um, Now, is it ungodly slow because it's shouldn't be caught in a loop? There shouldn't be like any while loop or anything that could cause it to spin out of control. And actually, wait, hold on. Stop. I think I did something wrong. I probably did a lot wrong. If we look at the invalid, we can't. Yeah, that's totally wrong. We're probably adding way too many numbers. We're adding as soon as we're saying as soon as you catch one that. Yeah, we have to do this in reverse. If the next doesn't equal the first, then we say false, and here we say true. I had that totally backwards. Because as soon as you find, like if you had 1, 2, and the next one is 3, 4, is it invalid, is false. Because there's no way that it could ever repeat. Now, it could repeat with 1, 2, 3, 4, 1, 2, 3, 4. That it could repeat, but the 1, 2 and the 3, 4 comparison, that comparison would immediately say it's not invalid. Now wait a minute. Okay, it's not false though, because of what I just said. We want to continue. So as soon as we found with the no, we want to break. Now, maybe. Yeah, I definitely had it wrong before. Now I just got to be a little bit careful as to how do I say it's invalid. It's invalid if we ever found a sequence of numbers repeating. Let me read the problem again. Yeah, it doesn't repeat with just a single check. With 2 it wouldn't repeat, but with 3 it does. And so you want to say is if you ever found all of them repeating, all the groups repeating, then that's a true. So like var all repeating. So if the next one equals that, then we say all repeating or equals true. No. We only want to see if we've caught all of them. Okay, so we're counting the number of times we've seen it repeating. If repeating is equal to the number of times we went through this, and the number of times we went through this is it's the length of the value content divided by 2 minus 1. Now it's true. Otherwise, if we do all of this, we never found a repeating, and we can say false. I think. Because the value content is 10, that means we would have gone through it 10 divided by 2, which is 5, but minus 1, which is 4, because those are the next. We would have had 4 groups there. 1, 2, 3, 4. And that means we would have found 4 repeatings. Probably still going to take forever because my algorithm is not nice. But yeah, we couldn't do what I thought we were going to do, which is we can only report if we find one that is okay. So, Guy, what is your stupid question? Because obviously I'm not doing this efficiently. There's probably a trick to the numbers that I'm just not realizing off the top of my head. So go look at their examples again. Yeah. Each invalid ID has an even number of digits. Well, that gets me half. I mean, yeah, you're right. But even if I remove half of them, I mean, I'm still it still hasn't finished. So that's not even remotely good enough. I mean, you're right. I'm not saying you're wrong. I get it. You're right. But that's not enough of an optimization to because that's just going to stop half of this. That's not going to stop all of it. So I'm going to stop this because obviously it's not. We can put that in. I can say if value content length is equal to 1, then we return false, because there's no way that that could actually ever work. But that's not right, guy. That's not right. What happens if I have a number like 983, 983, 983? This repeats, this repeats, this repeats, and that's an odd length. So that's an invalid statement. Sorry. So yeah, we can't do that. Like, I think if the number is not prime, if it's composite, we have to check it. Because 2, we'd have to check. 3, we don't. 4, we would. 5, we don't. 6, we would. 7, we can't. Well, no, that's not even true. Even if it's 7, we could say, what was if they had 1, 2, 3, 4, 5, 6, 7? That's an invalid ID. So I don't think we can make any kind, at least I don't think we can make any kind of assumption on that. I mean, I figured out the algorithm. It's very simple, fast, but I don't want to just say give you. I'm trying to figure out what to say to point you in the right direction. Well, I know. I mean, all of the Advent code problems I've ever seen, there's always a trick, and a trick meaning an algorithm, a way of doing the processing that if you notice it, you'll be like, oh yeah, this is really, 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 really simple. But it's the problem of somebody like me who doesn't have that kind of background to go, well, what am I missing here? How can I optimize this? How can I make this faster? How can I make this better? And I will admit, I don't have that. That's why sometimes I struggle with these problems, because I just don't have that insight at times. So but yeah, the thing about each invalid ID has an even number of digits. I mean, that I don't agree with. In the problem, you're right, they always have even, but you can have an invalid ID that is 555. That's invalid, and that's an odd number of digits. So how long have I been going? 2 hours. Yeah, I need to take a break and go to lunch. And then I want to play Halo this afternoon after I do a couple of things around the house. But yeah, I don't see what it is. Some sequence of digits repeated twice. Huh? In that sentence, I don't understand that sentence. Some sequence of digits repeated twice. Sentence starts with, since the young elf was doing silly patterns. You can find the invalidates by looking for any ID which is made only if some sequence of digits repeated twice. Oh. Yeah, that would help a lot. Okay. Yeah, I just realized it's the twice. That's what I wasn't catching by the problem statement. And I'm not trying to copium here, and I'm not trying to throw blame. Sometimes the way the Random.Code problems are written, they don't necessarily click with the way my head works. I mean, now that I see this, yes, it's the twice that matters. So you only have to say, take the number. If the length is even, divide it by 2, look at the first chunk and the second chunk. And if they equal, then yeah, you don't have to look for all of them. That's what I wasn't understanding by the way the problem was stated. So if we go into our extension here, we should be able to say, okay, if it is odd, can't happen. Now we just need to say if the value content as span if the value content is span, we need to go to 0 and then half the length, right? So if it's like 10, we want to get 5. If that sequence equals the value content as span, we want to start at value content length this but minus 1. Because if it's 10, no, wait a minute. 0, 1, 2, 3, 4. No, that's right. We want to start at 5. So we want to start at 5. And then we can just say go to the rest because it doesn't matter. Now we can say return true. And actually we'll be able to clean a lot of this up. Hold on a second. You were probably struggling trying not to give me a hint there, weren't you? Let's get rid of one of these. And then we can actually make this easier. We can say is it invalid? It's invalid. Return if the value content length is even and we do this check. That kind of simplifies it, doesn't it? And we made this generic. Okay, let me go through this again. So we get the length of the string, and getting a 2 string on a number, that is a little inefficient, but, you know, it is what it is. We really, you know, there may be a better way to do it, but I'm going to go with this for now. So any odd numbers, they're like odd length numbers, not odd numbers, odd length numbers, they're gone. It can only be invalid if it's an even length, and the first half is equal to the second half. I think that would work. What does that do to our test? Well, it failed. It failed rather quickly. And it found none of them. Yay! Woohoo! Don't debug it for me yet. Let's just do something simple. This should give us 11. Okay, so let's actually debug this and see where we're going with this. So the lower range is 11, the upper range is 13. Okay, so we take a look at 11. The value content length is 2. So 2 divided by 2 should be 0. Oh. Come on, chat, come on. Mod. There we go. Well, that's another one. Nah. Okay. That way, guy, thank you. I would have probably torn out what little hair I have on my head. Wait, we want solution day 2. Run part 1 on day 2 input. And then we want to say run day 2. Huh? Oh, it's just... Yeah, we want to just read it as one line. Just you wait. Await. Async task. Yes, I follow that nomenclature. Shut up. Async task. Async. Do that. And now we have to say await run day 1 async and await run day 2 async. All right, runs day 2, getting part 1, solution day 2, run part 1 on all of the input of day 2. What do we get? We get a number. Is that the right number? Thanks, guy. Okay. It helps to read the problem. It helps to read the problem. Alrighty. I am going to stop here because I've been going for 2 hours. I will, and that's why planes have co-pilots. Yeah, I feel kind of stupid because in retrospect, looking at that, the problem is actually stating exactly. I'm not going to do part 2. I'm not even going to look at it. But yeah, it says twice, and I really just did not pick up on that part. So this is showing me again that yes, having a co-pilot, pair programming does help. But it also just helps to read the damn thing correctly the first time. So, but yeah, that was really, I mean, the resulting solution, I don't have timings on this or anything like that, but the resulting solution is pretty quick when I run this. I mean, it's super fast. So, there may be a better way to do this parsing, but I kind of like this because it showed, the new extension syntax that's in C#. God, I almost said Visual Basic. What the hell's wrong with me? It has that new extension syntax there. This is now flexible for any binary number. So you could do this as long as it implements iBinary number. We're cool. And it also shows a nice little thing that people may not know is that you can have 128-bit integers. You can also use uint if you want. That's possible. We didn't have to just use int. So yeah, I did learn some things, and hopefully by what I was doing did show some other things that maybe people didn't see before. But I am going to stop for now. I want to thank everybody who's been watching either now or in the future. If you haven't subscribed to the channel just yet, please do so. I would greatly appreciate it. If you've already subscribed, I appreciate you for doing it. I'm going to do a couple things around the house, like eat lunch and stuff, but then I'm going to come back this afternoon roaring to play Halo Infinite and do more of that. Looking forward to that. I will be doing a Random Code stream definitely tomorrow morning. I don't know for the rest of the week what I'm going to be doing, but yeah, definitely tomorrow morning. The plan is to do another Random Code stream. But for now, I am done with this stream. Thank you all for watching. Take care, and I hope to see you in the future.